Hi, this is an introduction to how you can monetize your code in minutes using Dhali. I'm going to be guiding you through the steps of creating a YOLO-S tiny object detector as a Docker image and uploading it as an asset to the marketplace. Once you've done this, your asset can start generating an income for you. So let's jump straight in by navigating to our docs page and going to the Creating Dhali Assets section here. We can see that the first thing we need to do is to clone this Dhali asset template repo. So once we've cloned the repository, we can open it up in our favorite IDE. The first thing we'll need to do is we'll need to pass the input to the infer method as an image, because we'll be implementing an object detector which is operating on images. We can see how this is done by inspecting the comments section here. So to pass the input as an image, we run the following command. We'll need to import image from pill, and we'll need to import IO. To understand how we can implement a YOLO-S object detector, we can go to the Hugging Face YOLO-S page here. We scroll down, we get some source code which shows us how to implement this YOLO-S tiny object detector. So after having inspected the source code in Hugging Face, we've made the following modifications to main.py. Firstly, we've imported YOLO's image processor and YOLO's for object detection from transformers. We've imported torch, and we've instantiated model here and image processor here. It's important to recognize that these have been instantiated outside of the infer function. As a general rule, we want to make sure that things that can be instantiated outside of infer are instantiated outside of infer. This helps the infer method run as fast as possible, which will be important for asset consumers. Following this, as I mentioned before, we've passed the input as an image in this way. We've then performed some pre-processing and run inference using the model on the inputs. We've then performed some post-processing to get some results. And from the results, we've calculated scores, labels, and boxes, which we've returned in this dict, like so. After having updated main.py, we can go back to the documentation, and we can see that the next thing we need to do is to modify the README. So these are the modifications that we've made to the README's template. So we've added a short description of the model. We've described what the inputs of the model need to be, and we've described what the model's output is going to look like. This README is the thing that will be displayed to users of the model when they view it through the marketplace. So next, we need to add the dependencies of the YOLO-S detector. We do this by modifying the requirements file, requirements.txt file. So the three modifications that we made are these 3 lines here. Now that we've determined the dependencies of the asset that we're creating, we can run the model locally. To do this, we first need to pip install the requirements.txt file, like so. And then we can spin up a UVcorn server using the following command. What will happen when this UVcorn server spins up is, first of all, it'll start downloading the model from Hugging Face, which you can see happening here. Once this is downloaded, we can kill the UVcorn server, and we'll now see that the model has been downloaded to this point in our directory system. It's important to recognize that the reason it's been placed at this point in our system is because we included the cache dir argument here and set it equal to the empty string. This is important for making sure that we can copy the model into our Docker file into our Docker image in the next step. So now that we've pulled the model into our local file system, we can move on to the next step, which is to modify the Docker file here. So I'll go and take a look at the modification that we needed to make. So this was the line that we added to the template repo. So we copied the model file that we just pulled from Hugging Face into this place within our Docker container, within our Docker image. And with that, we can now build and test our asset locally. So the first thing we'll do is we'll Docker build using this command. So now that that's built, we can run it using this command. What I can then do hit the asset using this command here. Just copy that. I'll modify this path so it points to a file on my system. And I'll click run. And you can see we get a result. So we get this dict here, which is what we sort of said we would get in the README. The detected object that came with a 99% confidence that the object was of label 25, which we'll take a look at in a moment. And the detected object had the following bounding box coordinates. So if we go to the Cocoa 2017 labels, we can see that label 25 is the following. So it is a giraffe, which is unsurprising given that we sent it a picture of a giraffe. So I reckon that's pretty good, and we're ready to deploy this asset. So to deploy the asset, we'll go back to the documentation and we'll take this command here. What this is doing is it's taking the Docker image on our system and it's going to convert it into a file called myasset.tar. So I'll run that command. So now that that's run, we can see that we've got this myasset.tar file on our file system. The next thing we need to do is to go back to the landing page and navigate to the marketplace. So when we enter the marketplace, we'll be shown this screen. First thing we need to do is activate a wallet. Got a few wallets we can select from. For this demo, we'll choose a raw XRP wallet. We'll generate a new wallet. This will take a moment. And then we'll continue to the assets page. You can see we've got no assets for this wallet at the moment. That's because it's a new wallet. So what we'll do is we'll add a new one. So we'll give it a name, YOLOS Tiny, and we'll select the tar file that we just built a moment ago. We'll also select our README, and we'll click next. Scans the image, make sure it's not too big. At the moment we have a 7 gig limit on images. We're going to increase this in the future. Click next. We have to set an earnings rate for the asset. So the earnings rate is the amount that we'll earn as the asset creators on top of the compute cost incurred by Dhali. So it costs $1 in compute to run this asset for some period of time. When the asset's used for that period of time, we'll gain 20 cents. Click next, and then we get a breakdown here of the cost associated with deploying the asset as well as the earnings associated with the asset. And we can click yes, and this will start deploying. Okay then, so brilliant. That is now deployed into Dhali, and you can see it's telling me that my NFT has been successfully minted. So there's a couple of key things we want to look at now. So the first thing is if we exit, we can see now on our My Assets page that we have an asset that's visible to us. If we go to the marketplace, we can see that this asset is visible in the marketplace as well. We can click on the asset. In a moment, we'll see the README that we uploaded when we deployed the asset. What we can also do is we can go back to our wallet, we can copy our classic address, we can jump into the testnet, and we can see the assets that we own in the testnet. If we click on non-fungible tokens, we can actually see this NFT that our wallet now owns. And you can see it's been embedded. The URI has got this UUID element embedded in it. And this UUID is the same as the UUID of the asset, which you can view in the URL here. And so finally, to finish off the demo, what we'll do is we'll actually use the asset that we've just deployed. So to see how this is done, we can go to the docs page and we can scroll down to using Dhali assets. The first thing we'll need to do is to make sure Dhali Pi is installed. We did that before. We'll then create a new XRP wallet. So you can see that we've just done that here. And finally, we'll take this command, which will be generating a payment claim for us that we'll be able to embed in the header of the requests that we make to Dhali. So I'm just going to make a few changes to this. So I'm going to take this secret, put that there, and I'm going to take the sequence number as well. Place that there. What this will do is it will generate a payment claim for me. And once I've got a payment claim, I'll be able to send requests to the Dhali asset. So my Dhali asset is YOLO S Tiny. It has this particular endpoint, which I can copy in like so. Go back to the documentation. I can see that my request looks like the following. So I'm just going to precede the URL with that. I've also got to put the payment claim in there as well. In the header, close those quotes. So the payment claim that I've got to put in is this thing here, the output of the create XRPL payment claim that I ran a minute ago. So I'll put that payment claim inside that string. I'll put a space there. Sorry, I forgot to provide an input. So similar format as before. Pass an input to the asset like this. So home /Dave /pictures /giraffe.jpg and go. Give it a second, and we get our result. There you go. Same result that we saw before. So it's a 99% confidence that the image was of label 25, and the bounding box of the detected object was that. So there you go. Deploying Dhali assets that can now generate an income for us.